Hi, I'm Mark Cantrell, Applications Engineer for the iCoupler Digital Isolator Group. I'd like to talk to you about reinforced insulation and to show you how our iCoupler digital isolators meet the same requirements as optocouplers under the IEC 60747-5-5 safety standard. Reinforced insulation means that an isolator is tested to be equivalent to a double-layer insulation system as required for medical and offline applications. There are three ways that the safety agencies test reinforced insulation. The first is the voltage withstand level, a simple 1-minute AC overvoltage test which broadly indicates the insulation strength. Second is a partial discharge test to detect the presence of voids in the insulation. The third is surge testing, where a high voltage transient pulse simulates lightning strikes in power and data systems. The surge testing is the most severe of these methods for thin insulation and often differentiates isolators. Let's take a look at three types of isolators and see how they compare in the surge test. Optocouplers use an injection molded polymer epoxy in the package assembly. Epoxy can allow insulation voids, so optocouplers use thicker insulation to compensate. Our iCoupler digital isolators use a thin, void-free polyimide polymer layer deposited during wafer fabrication. Capacitive isolators use an even thinner, void-free silicon dioxide layer. The IEC standard requires that every reinforced isolator withstand surges of 10 kilovolts. Let's look at how this type of test is done and see how different types of insulation hold up. We're using an ESD tester and bleed down resistor to get approximately the waveform we need. Note the fast rise and slow decay peaking at 10 kilovolts of the open circuit fixture. Now let's surge a 5 kV rated optocoupler. It passes the 10 kV requirement, and the pulse looks similar to the open circuit case, so the insulation is intact. Polymers do well in surge environments. Now let's look at a 5 kV rated iCoupler. It also survives the surge. Like the optocoupler, it's also a polymer insulation system, just thinner and of higher quality, and also very tolerant to surge stress. Finally, let's look at a 5 kV capacitive isolator that uses silicon dioxide insulation. As you can see from the sharp drop in the output voltage, the surge broke through the silicon dioxide and dumped the charge from the tester. Even though this product is rated at 5 kV RMS, its inability to pass this 10 kV surge test suggests that it would not be able to meet the IEC 60747-5-5 requirements for reinforced insulation. These results demonstrate the advantages of polymer-based systems for reinforced insulation. Only polymer-based isolation has demonstrated compliance with IEC or equivalent standards. Analog Devices iCoupler meets the same safety requirements as optocouplers.